Alrighty, hello everyone, this is the Lab 7 video. So again, we're continuing with statistical inference. In Lab 6, we estimated a population proportion P. In Lab 7, we're going to estimate a population mean mu. Remember, this is the Greek letter mu. So once we get to the confidence interval and hypothesis test, it's very similar steps. You will need StatCrunch. In this lab, especially when you get to the hypothesis test, you will need StatCrunch. Okay, so the same concept, we're estimating an unknown value, an unknown population parameter, but just a different parameter. So there's some differences here once we get to the steps. Okay, how does a short exercise routine affect college students? Again, we're going to assume this class represents a random sample. We know it does not, but we're going to assume that it does. Just like in Lab 6, the taste test was voluntary. The exercise is also voluntary. We do need to collect the data, but if there's a health issue or you're concerned about something, it's totally voluntary. Just let your lab instructor know. Also, you need to work in groups for this one. That will make the data collection a lot easier. Okay, so in groups, you will do a very short exercise routine. You'll just do some knee raises. Your lab instructor will demonstrate. You'll just pick your knee up, grab your knee, put it down, then switch legs. So just very simple, quick exercise. Our main research question is mean heart rate after exercise greater than 110 beats per minute. You see greater than here, so you should be thinking your alternate hypothesis form definitely needs to be greater than, right? Since that's the research question. Okay, so work in groups of 2. First, everyone needs to find your pulse either on your neck or your wrist while sitting down just at rest. Once you find your pulse, count the number of heartbeats for 15 seconds. Count your heartbeats for 15 seconds. Multiply this count by 4 to get your beats per minute. In table 7.1, that will go in HRB 60, heart rate before exercise, then 60. Okay, so that is your resting BPM, resting beats per minute. Now, that's your baseline. Now you need to do the exercise. So once you have the heart rate before, you'll take turns doing the exercises. So you'll just do low intensity knee raises for 30 seconds. You'll take turns, one person keep the time, one person do the exercise. After you do the exercise, find your heartbeat, count the number of beats, again, for 15 seconds, multiply that by 4, the BPM, the heartbeats by 4, to get HRA 60 in table 7.1. You need HRB 60 and HRA 60. Then you need your heart rate increase. So your heart rate increase will be the heart rate after exercise minus the heart rate before exercise. Right? That's the increase. That's the rate of increase. After exercise minus before exercise. Then in 7.2, you will put the combined data from the entire class. The lab instructor will collect all the data. Then you'll put all the data, all the class data in 7.2, table 7.2. In 7.3, you can transfer over that data into StatCrunch. Since you should be comfortable now calculating these things, you can use StatCrunch to calculate descriptive statistics for HRA 60 in HRI. You'll get the sample mean, the sample median, standard deviation, things like that. And then in 7.4, you will get a confidence interval for mean HRI. You'll get a confidence interval for mean HRI. Then in 7.5, you'll do a hypothesis test for HRA 60, for HRA. Remember the original research question for the hypothesis test. Is mean HRA greater than 110? That will be your hypothesis test. For 7.4, the confidence interval, you do need to practice doing that by hand because you have to use the t-table to get the critical value. Excuse me. So the critical value, you must use the t-table. 7.5, you can put that. For the p-value, you can use StatCrunch. Okay. And then you'll answer the discussion questions. Same concept, it's still a confidence interval for an unknown value and then a hypothesis test, but now we're doing this for one mean instead of for a proportion. Make sure you use the t-table to get the critical value. Again, here's your questions. So your hypotheses should look like this, right? For the hypothesis test. And you're doing this for heart rate after exercise. The confidence interval, you're getting a confidence interval for the heart rate increase. How much on average does the heart rate increase from before exercise to after exercise? And then you'll answer the discussion questions. Okay, the lecture recall is also in here. So we definitely recommend you use the lecture recall if you need a refresher on anything. Okay, that is the end of this video.